the length of a steel wire is L1 when the stretching force is T1 and L2 when the stretching force is T2. The natural length of the wire is, and there are 4 options. Now so the length is L1 when force T1 and L2 when force T2. Now to find the natural length, that we know Y, that is Young's modulus, is equal to force divided by area, that is stress, divided by strain, that is delta L by L. So here L is the natural length. Now for the first case, that is when length of a steel wire is L1 when the force is T1, that is delta L is equal to TL divided by AY. So for the first case, delta L is L1 minus L, and this is the stretching force is T1, so T1 L divided by AY. Let's say this is equation number 1, and for the second case, the change in length, that is L2 minus L, is equal to T2 L divided by AY. Let's say this is equation number 2. Now if you divide 1 by 2, that is L1 minus L divided by L2 minus L, then T1 L divided by AY into T2 L divided by AY. So L AY cancels and this is equal to T1 by T2. Now if we multiply this, T2 L1 minus L is equal to T1 L2 minus L. From here we can write T1 L minus T2 L is equal to T1 L2 T1 minus L1 T2. If we take L as common, then T1 minus T2 is equal to L2 T1 minus L1 T2, or L is equal to L2 T1 minus L1 T2 divided by T1 minus T2. So the correct option is option C. So the natural length is L2 T1 minus L1 T2 by T1 minus T2.